We're looking at proportional reasoning, and the method we're going to use to solve the question today is unit rate. Overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to make comparisons using unit rate. So here's our inquiry type question. We'll read through it once. We'll highlight what's important the second time we read through it. On a sunny day, a flagpole that is 6 meters tall casts a shadow that is 2.4 meters long. At the same time, a tree beside the flagpole casts a shadow that is 4 meters long. How tall is the tree? Okay, this one's relatively straightforward. Let's highlight what we think is important. On a sunny day, a flagpole that is 6 meters tall, casts a shadow that is 2.4 meters long. At the same time, and I'll highlight the tree in a different color. At the same time, the tree beside the flagpole casts a shadow, shadow that is 4 meters long. And then how tall is the tree? And I guess I should highlight this part. The shadow is this long, and the flagpole's height is that long. Okay, because this one is set up with kind of a visual description, let's try to actually draw this out. So we'll use this line here in black to represent the height of the flagpole. So here's our flagpole here. And then it's going to cast a shadow. Let's put the shadow maybe in gray. Okay, so here's our gray shadow. It said that the flagpole, the original flagpole, was 6 meters tall, and that it cast a shadow that was 2.4 meters in length. It also said there is a tree. So let's draw that tree. We'll use the line again. We'll put the tree in green. And I'm going to put the tree a little taller. And the reason being is, as you're going to see in a second, the shadow of the tree is a bit longer than the shadow of the flagpole. The shadow of the flagpole, they said, was 4 meters long. So if the shadow is longer, then we can kind of go on the assumption that everything else being the same, that this would be taller than the flagpole, right? That way it's casting a longer shadow at that same angle. Okay, so in this question, we're going to be using unit rate to try and solve this. So we're going to set up our two categories here. And the two categories, though we have a flagpole, so we have our flagpole and our tree, Our categories are really the shadow length, and height of the object. So let's build those two categories. We'll have our shadow and our height. And the two objects are our flagpole and our tree. So if you've noticed, I've made 2 columns and 2 rows to help set this all up. So our flagpole's shadow was 2.4 meters in length, and the tree's shadow was 4 meters in length. The height of the flagpole was 6 meters, and the height of the tree is our unknown. So we have our unknown. Now we want to build a unit rate. So what I'm going to do here is I'm going to pull this down, and our unit rate here, so move our tree and this down so we can build our unit rate in between. Now our unit rate, like we're saying, so I'll call this our unit rate. There are essentially 2 unit rates we can do. We can do height, and a lot of times I use the word per. So we could do something height over shadow, or technically we could do the shadow over height. And sometimes this be described when there's like ratio relationships, that maybe height and the line here usually means per, and per means 1. So height per shadow, And really what we're talking about is the height per meter that the shadow is, So we want to know per meter. Or we could do the opposite relationship down here, the shadow per height in meters, per being 1 again. So the shadow per 1 meter in height of the object, So we're going to build the 2 unit rates. And actually, again, I'll move this down. So we have the 2 unit rates, and we can see how we'll get the same answer using both. So our first unit rate, we said we were going to do it in terms of the shadow coming second, so per 1 meter. We want shadow to be 1 meter in that case, And our other unit rate, I'll just set it up, was the opposite. We wanted it where the height to be in meters, so that's where we'll refer that to 1. And you'll see that we'll be able to get the same answer using both. So in order to do this, we need this 2.4 to be converted to 1 meter. Okay, we can use a relationship that's decreasing, and one of the ways we could do this is we know that if we divide 2.4 by itself, okay, so we divide by 2.4, I guess we'll do it in red, okay, we would get the value of 1, so we're dividing by 2.4. And because we did this to the shadow's flagpole length, we're going to do the same to the height. We're going to divide that by 2.4, so we're dividing it by 2.4. And that will give us kind of what they sometimes refer to as our rate when doing these things. So let's bring out our calculator. Okay, so 6 divided by 2.4 equals 2.5. Great. So we get a value of 2.5 meters. So let's just kind of continue this, and then we'll use the green unit rate secondly to solve. What we then want to do, so because now this is a meter, we want to have an increasing relationship to get to the number 4. Okay, well, we know we can increase the relationship by multiplying, and I guess I'll do it on this side here. We're going to multiply by the number 4 to get up there. And because we did that to the 1, we're going to do that to the 2.5 also. We're going to multiply by 4. So I'm going to take out our calculator, and 2.5 times 4 gives us 10. So according to this, the height, I guess I'll erase that there, the height of this object is 10 meters, and the object being the tree. Okay, so we use the red unit rate, where we use shadow as to be 1 meter. But what if we convert height to 1 meter? Same idea, okay? This time, we want 6 to turn into 1. So we've already got our answer. We're just using another method now. Same idea to start. We're going to divide 6 by itself. We're going to divide it by 6. Because we divided the height of the flagpole by 6, we'll also have to divide the shadow of the flagpole. We'll divide that by 6, okay? So we take our 2.4, and you notice we're going to get a decimal here. 2.4 divided by 6, 0.4. So now our value is 0.4. So remember, at this point, technically, though we already got our answer, our unknown was still the height, right? So what we need to do is we need to multiply or use an increasing relationship to take 0.4 to the number 4. Now, this could be difficult. One way you can do this is take 4 and divide by 0.4 in your calculator. And I'll talk about a trick later. We take 4 and divide by 0.4, and we get 10. Another way to look at that is because these two values were 4 and 4, right? We're using the same kind of number value here. It's just in a different decimal place. If we multiply by 10, it moves the decimal over 1. So that's another way of telling we multiply by 10. So I have to multiply by 10, and because I did that to the our value here, we'll have to do it again over here, and lo and behold, we get 10 meters once again. So it didn't matter which unit rate we used, we were able to figure out that the height of the tree in this case must have been 10 meters. If you'd like to look at other ways or find other ways to solve this type of question, look at our other playlist dealing with proportional reasoning.